Question 7. The gradient of a curve is given by that differential equation, and it passes through the point 1, 1. By solving the differential equation, get that particularly horrible looking answer. Right, it is a differential equation, although it's written not how we often have them presented. So what we want with differential equations is we want to have just the two sides of the equation. So our first move is going to be to write that. Now we talked about separating the variables before we integrate. So what we want from this is we want to get everything involving y on the side where dy is on the top, and everything involving x on the other side. It's all wrong at the moment. So what I'm going to do is I'm going to divide both sides by minus 4y squared, and I'm going to divide both sides by 2x plus 1 cubed and get it to look like that. I have to do that because I have to get stuff involving y onto the left, because dy is on the top on the left, and stuff involving x onto the right. That's a big thing, because before you can get anywhere with this question, you have to be doing that step. Now we can integrate. We're integrating both sides with respect to x. It gives us the integral of minus 1 over 4y squared dy, because the dx cancels out, is the integral of 1 over 2x minus 1 cubed dx. Now, one thing I just think is worth us thinking about at this point in this question is that the answer that we're heading for doesn't have a single natural logarithm term in it. And there's a big clue there, because once we've created a natural logarithm term, we're not going to be able to get rid of it in this kind of question. So neither of these sides of these, although it's all fractions, neither of them are things that integrate to give us a natural log. Because it's only 1 over x or 1 over y that gives us natural log. The power has to be 1 on the bottom to get natural log as the answer. Neither of these have that. You might want to think of these as being minus a quarter times the integral of y to the minus 2 dy. And you might want to think of this one as being 2x minus 1 to the minus 3 dx. Because that, I think, puts it in a more familiar form. You add 1 to the power and divide by the new power. You add 1 to the power and divide by the new power, but also by the coefficient of x. And we have to write plus c, because we've just integrated without there being limits. So we always must remember the constant of integration. It's all looking a little bit messy, so I'm going to try and tidy this up a little bit. I've got minus 1 over minus 1, so that cancels out. I've got 1 over 4y, I think, out of that left-hand side. And my right-hand side is looking like it is minus 1 over 4 times 2x minus 1 squared plus c. I think that's where I am with this at this point. Now we need to check, what did the question say? It said it passes through the point 1, 1. So, if x equals 1, y equals 1. That gives me a quarter is minus 1 over 4 lots of 1 squared plus c. So I reckon out of that I get c equals a half. I think. Does that look right? So, where am I now? I've got 1 over 4y is minus 1 over 4 lots of 2x minus 1 squared plus a half. I don't have to do this at this point, but it feels like I've got a quarter as a thing that's happening all over the place. So, oh, Danny's looking at me. Okay, maybe I won't do that.
No, you should.
Oh, I will. So that I'm going to write 1 over y is minus 1 over 2x minus 1 squared plus 2. Because I've multiplied everything by 4 to get to that point. Right, I'm supposed to get y equals. At the moment I've got 1 over y equals. I have to be really careful now because there's be a temptation at this stage to just turn everything upside down and write the wrong line that would be y equals minus 2x minus 1 squared plus a half. We know that that line would be wrong, don't we? Because we know that if we're doing something like a half plus a third, you can't just turn that upside down and get anything meaningful out of it. Remember, a half plus a third is 5/6. But if you do 2 plus 3, you definitely don't get 6/5. So it just doesn't make sense to just turn everything upside down. So that's all wrong. Let's get rid of that before anybody looks at it. We need to, if we're going to just take the reciprocal of both sides, we need to get both sides as a single fraction. So we do have 1 over y. I think that's what I would do. If we put it as a single fraction, that's minus 1 over 2x minus 1 squared plus 2 lots of 2x minus 1 squared over 2x minus 1 squared. You see what we've done there? I'm just trying to put it over a common denominator. Which gives me 1 over y is minus 1 plus 2 lots of 4x squared minus 4x plus 1 all over 2x minus 1 squared. Okay, I thought I'd do a cheeky little multiply out of that bracket in the middle of everything else. 1 over y is now, let's try and collect a few things together. We have 8x squared on the top, minus 8x. We've got a plus 2, take away 1. So that's a plus 1. And the bottom line has a 4x squared minus 4x plus 1. I now have a single term on each side, a single fraction term, so I can take the reciprocal of both sides now. Y equals 4x squared minus 4x plus 1 over 8x squared minus 8x plus 1, and that is the values. And it does match up because remember it said ax squared minus ax plus 1 over bx squared minus bx plus 1. So a is 4 and b is 8, although you didn't have to state those. That's all right to have it in that form. That, again, especially that page was a bit of a killer, wasn't it? So that was quite hard. There we go.